Now that we have all of our Lego bricks assembled, we can start playing with them. With the Flow emulator process running, open up another tab in the terminal, and we can start executing our commands. By the way, the following commands work for all Flow environments, not just the emulator. The emulator is just the default if you don't explicitly set a different network flag. To start our interactions with the Flow emulator, we want to create an account. Before we can do that, we'll need a key pair. Remember, the blockchain uses cryptography to determine ownership. The Flow CLI has a handy command to create keys. It's flow keys generate. And then we're going to pick a specific signature algorithm, which is the same algorithm that Bitcoin uses, and enter. Now let's ignore this warning because for some reason Ubuntu still downloads version 0.26. And let's look at the private key and public key that we got. We're going to use the public key when creating an account. With our keys in hand, we can create our first account. Please note that we must identify the signature algorithm if it's not the default ECDSAP256. Also, since creating an account is just a regular transaction under the hood, an account must sign it. Thankfully, the emulator comes pre-populated with emulator account that will allow us to sign this account creation transaction. So let's write it out. Flow accounts create, and we're going to provide the key, the public key that we got from our keys. All right. Then we're going to note that the signature algorithm is this one. And we're going to set the signer as emulator account, since that's the service account that the emulator comes pre-populated with. All right. If the command succeeds, you'll get an account address in the response. Quick note, unlike Ethereum and some other chains, the address is not derived from the public key. This means that simply having a public key is not enough to identify an account. Further, to confirm it all worked, you can get account information by running the get account command. So we're going to take the address and do a lookup. Flow accounts get and the account address. Here we go. So we should see a balance and our associated keys. Please refer to the documentation for more details on the Flow CLI account commands. Finally, we can update our flow.json by adding this newly generated account, and we're going to use the long form key definition. I'm going to launch VS Code. I have it open right here. Select flow.json, and under accounts, we're going to add a new account. Let's call it emulator artist. All right. Now the address is whatever we got right here. Okay. And the key information, since we generated this with a signature algorithm, that's not the default. So we're going to just type out, this is a hex encoded key with, this is the first key, so the index is 0. Accounts can have more than one key. Signature algorithm is the one we picked earlier. The keys also have a hash algorithm. We're just going to use the default SHA-3. And we supply the private key. This is going to be used for signing our transactions. Okay, so this should be good. We save this and we're ready to move on. Great, so we have an account. Now let's use it to deploy our Hello contract that's located in the Hello folder. Let's see if it's actually there. All right. Notice how we're no longer using log for our greeting. That's because logging only works on Flow Playground and in the Cadence REPL shell. Instead, we're going to return a greeting as a string. Another change we're making, we're adding an event. When interacting with a contract, it's useful to have events as a way to communicate when certain things happen. Transactions don't have return statements and don't print logs in the emulator, so using events will allow us to see our greeting since we pass it on as an argument to the event. For more on events, please refer to the docs. With this information, let's update our flow.json to include information on our hello contract. So the path is hello/contract.cdc. Now, since we have an account and we have our contract, we're operating in the emulator network, we're ready to set a deployment target. So the way it goes is we pick a network working in the emulator. Then we set the account. We're working with the emulator artist account. And then we set an array of all the contracts that will be deployed to this account. At this point, we should be ready to deploy this project. If we did everything right, we should see this output where it says hello deployed to our address. And this gives us the transaction ID. Please refer to the docs for more details on deploying projects. Congratulations, we now have our first real smart contract deployed with an account. Let's waste no time and go play with it. The easiest way to do that will be to execute a script. Let's see what that script looks like. All right, same as with our updated hello contract, we'll modify the original script from day 2 to return a string instead of logging it. Also, we'll provide a name string as an argument instead of hard coding that name. It's more fun that way. One caveat is we have to comment out the event emitter from our contract because scripts don't support events. So this is a helpful showcase of us being able to redeploy contracts. So we can go to flow project deploy update. All right, so we updated our hello contract with emulator artist. And now we can execute our scripts. To execute, we use the flow scripts execute command, and we provided with a path to our script. So say hi, script, and let's see. All right, so we get an error. We missed an argument since our script now takes in a name argument. So to provide an argument, there's 2 ways. One is by providing the arg flag and the argument type :value. So we're going to say hi fast forward. All right, we execute and we get a result: hi fast forward. We can also use JSON to encode our arguments. So we're just going to do flow scripts execute hello say hi script, and we're going to feed args JSON equals and provide the JSON. Remember, the top level needs to be an array because this is the entire arguments array. Let's test it out. Yep, still works. Please refer to the docs for more details on scripts as well as how to encode cadence values into JSON like we did for our name argument. So read-only access to the Flow blockchain with scripts is cool, but you know what's even cooler? Transactions. Let's take a look. Flow transactions go through a pipeline that starts with Cadence source code, and we proceed to build it, which is a step that encodes the source code using the RLP or recursive length prefix encoding. Then we sign the encoded transaction. using the cryptographic keys that we associated with our accounts. Once we built it and signed it, we can deliver the transaction to a Flow access node. For more, please refer to the docs, and let's go ahead and build it. We have a sample transaction in sayhi.transaction.cdc. Let's take a look. What happens here is we execute say hi, and we don't really log anything. Let's not forget to uncomment the emit so that our events do get triggered, and redeploy our contract. Okay, so our transaction is built using the transactions build command. We feed it the source code, so that is sayhi.transaction, and we have to provide a few arguments. First, the authorizer, and we only have one account, so that's the account that we'll provide. Authorizer is the account that we have access to in the prepare phase, and that's the account that's going to be signing this transaction. Then proposer, so this is the account that will propose this transaction, and Flow will use the accounts increment functionality to make sure that only one instance of this transaction ever exists. Then we have payer. So we're going to be paying for the transaction costs. And again, we just provide emulator artist. Then in our output, we want to filter out just the payload, which is going to be the RLP encoded source code. And lastly, we're going to save this output into transaction.build.rlp. Okay, we see that the transaction got built. The resulting file encodes our source code as well as the necessary payer, proposer, and authorizer information as we saw. We can then proceed to sign it with our emulator account, and we have another handy command, flow transactions sign. We provide a path to the built transaction. Then we provide a signer. Again, we're just using the emulator artist. We're going to filter out just the payload, and we're going to save it to transaction.signed.rlp. One last bit, if we don't provide a flag, this will ask us to confirm if we want to sign it or not. By providing the -y flag, it will just auto confirm. Alrighty, so we have our signed transaction ready, and we can finally send it to our emulator for processing. So that's another command. Let's clear out the terminal. Flow transactions send signed, and we give it a path to the signed transaction. Alrighty, if all goes well, as part of the response, we should see our event that we defined earlier in the contract, and we can see that we do in fact have a greeting, and it says hi, our account address. Lastly, I want to mention that even though we went through each step of the transaction pipeline, we did that to get a better understanding of how it works. That is not necessary for when you're doing this multiple times. There's a shortcut. So we're going forward, we're going to use that shortcut version, which is a flow transactions send. We give it the source code, say hi transaction.cdc, and we provide it with an argument of who's signing this transaction. All right, and we get the same result. We're getting closer and closer to our goal of shipping decentralized applications, and today's quests will take us just one step away from the finish line. Let's go get it. You'll find stubs for these quests in the artist folder, and we have 3 quests for today. First one is the event calendar. We saw how to use events for notifying when things happen when we issue transactions, and it'll be great to add these 2 events to our artist contract from day 2. The next quest is printer goes burr. This is where we will implement a create collection transaction where we'll enable other accounts to start hosting our pictures, and a print transaction that will enable those accounts to print any canvas and store the picture in their collection. And finally, what you got, this is a script where we'll list and print all of the pictures that are stored with a specific account's collection. Best of luck on your quests.